Good. I can see the thumbs up. So there's 52 of you now. So I think we can start our lecture now. All right. So welcome back. We are now at our second week of our lecture. So I think last week we have learned about the resolution of forces. Sorry, the resultant of forces, right? So what means that when you have a lot of forces, right? You try to make one resultant forces from the multiple forces so that it will simplify our analysis on the system or a building, all right? But today we are going to learn the exact opposite of that, right? So before we have a lot of forces, right? We have a lot of forces. So you want to make it into one resultant forces so that it simplifies our analysis on a system or a building, all right? But today, the resolution of forces, it's the exact opposite. So what I mean by that is that we have one resultant forces, so we are trying to change it into a lot of smaller forces, right? So you are doing kind of like a reverse engineering. So why is it important? For example, you have a building here, right? And then what you have one big force here. So sometimes you want to break down the forces to further analyze which force is the strongest that is going to the right? So when you resolve these forces here, you will have something like smaller forces here, smaller forces there, smaller forces there, and smaller forces there, right? Only when you resolve it, then can you know the multiple smaller forces here. And then from the smaller forces here, you can design the building based on specific forces here, right? So that's why we take one big force and we divide them into smaller and multiple forces. That process, it's called the resolution of forces, right? And for this week we are still doing it in two dimension, which is in 2D space. So the first question is, how do we break down the big forces into smaller forces, which is how do we resolve the forces into small force. So it's the same thing like doing in the resultant force, right? You just for perpendicular. This is for perpendicular. It's the we try to do the easier one first, which is perpendicular, 90-degree. So it's the same thing. You have one resultant force here. You just make one big box here from the resultant force, and this will be your Fy and this will be your Fx, right? It's the same thing. You have one resultant force here, then you just draw a line here, and then this part will be your F in the Y direction, and this part here will be your force in the X direction. Now you have resolved the resultant force here into a force in the Y direction and a force in the X direction, right? This is for the easier one, which is the perpendicular. It is 90-degree to each other. All right. Now, Fx and Fy can be calculated using the principle of trigonometry, right? So just by using basic trigonometry, you can find the magnitude of F in the Y direction and the magnitude of X, the magnitude of force in the X direction, right? Force in the X direction and force in the Y direction. So how do we solve it? It's just using cos theta and sine alpha, right? So for example, if you want to find the magnitude of F here, so you use cos theta, right? Why cos? Because cos is adjacent over hypotenuse, right? So if you want to find the force here, which is force in the Y direction here, if you're using the angle here, so it's fx sine theta, right? If you're using alpha here, then obviously the signature here changes. All right. So it depends on where you want to solve it and where you have the data. All right. For example, if fx here and you are using angle here, so f cos theta. But if you're using alpha here, the fx is here, All right. So using F sine alpha because opposite, right? Opposite over hypotenuse. Okay. So depending on which angle you have, you use specific sign to solve that problem, right? But that's just about it. How to find the magnitude of F in the X and F in the Y is using the principle of trigonometry. Okay. So there's also another way to solve it is by using the ratio method, right? So using the ratio method is like this. You have your resultant force and the ratio is also already given here in the triangle, right? So 3 here and 4 here, okay? So 3, 4, OAB here, it's equivalent to OAB here, right? So if you want to find fx, for example, so fx is equals to f is equals to 4 over 5 because the ratio is already given here, all right? Because you want to find this one here, so it's the ratio of this one over this one, right? It's the same thing if you want to find the vertical magnitude, all right? If you want to find the the vertical magnitude, which is Fy here, so it's equals to Fy equals to F3 over 5, right? F3 over 5. Why 3? Because this is the vertical part, right? This is equivalent, right? So you take the 3 and you divide it with the hypotenuse, right? Remember, a lot of students, they make this mistake where the ratio is already given in the question, but they still calculate the problem using angles. They're still calculating 30-degree here, for 20-degree here, 10-degree here. It's just a waste of your time, and the question is just tricking you. All right. If the ratio is already given, you don't have to calculate the angles and so on. Right. And during the last final exam, I gave both the ratio method and I gave a complicated way to calculate the angle. And then the students still calculated the angle, even though it's taking time and it's more complicated than just using the ratio method, right? Because okay, in this chapter, you're going to calculate angles a lot, right? So sometimes you get accustomed to it. But if the ratio is already given, you don't have to calculate the angle because the ratio you just have to use the ratio to calculate the magnitude, or you just have to use the ratio here to calculate the magnitude. You don't have to calculate the angle anymore, right? So for example, if you want to find fx, just use the horizontal component, divide by the hypotenuse. If we want to find the vertical component here, take the vertical component here and divide it with the hypotenuse, this one. All right, remember that. If the ratio is already given, you don't have to solve or find the angle for each and every triangle in the problem set. All right. So if ratio is given, straight away use the ratio to calculate the magnitude. So it will save you time. Okay. Usually when the ratio method is given and you calculate the angles again, it means that the student, they do not understand what they are doing, right? They just memorized the solution, right? So they just memorize, okay, first you need to find this one and then this one and then this one. When you do that, it's going to be a bit confusing for you. If I change the question a little bit, and then you are going to get confused, right? So try to know what you are doing when calculating your solution, right? So for example, here, if you want to find the magnitude and the the way to calculate is already given, which is the ratio here. The ratio is already given, so you don't have to calculate the angles and so on, right? Granted, we calculate a lot of angles in this chapter and the next chapter and so on. But if we have a way to simplify it, for example, here, the ratio is already given, then might as well just use it. Save you a lot of time and save you a lot of headache during your tests or your final exam, right? So this is the second method, the ratio method. If it's given, straight away use the ratio, right? So this is what I've been telling you. So the hypotenuse is the same thing. OA plus AB is equals OB. And you can find Fx from the ratio itself, right? You don't have to calculate cos theta, sin theta. Just straight away use this one. -4/5 and 3/5. This is the hypotenuse. This is the horizontal component. This is the vertical component. It's negative because this one is going into the negative direction, right? So you have to be careful about the signage as well. This one is going up, so it's positive, and this one is going to the left, so it's negative. So that's why it's minus -4/5, and this one is 3/5. Okay, so that's the second method of resolution of forces in perpendicular components is using the ratio method. Okay, so what happens now when it is in non-perpendicular component? Means that it's no longer 90°, right? Even if it's no longer 90°, the way we solve it is still the same. You have one resultant force here. We just make a box or make a parallelogram to find the forces in the x direction and to find the forces in the y direction. So we have one resultant force here. Just make a parallelogram here. And then this one will be your Fy. And then this one will be your Fx, right? Remember, resolving forces. Resolving it means that we are breaking down the resultant forces into force in the y direction and in the x direction because we are still in 2D, right? So this will translate into this, right? We have one resultant force here. Once we have resolved it, we have force 1 and then we have force 2 here. Okay. Now, how do we solve it when it's in non-perpendicular component? It's basically just using the sine rule. So last week we have learned about the sine rule, right? So sine rule is just F1 divided by sine theta is equals to F2 divided by sine alpha divided by sine beta and so on, right? The trick here is just to remember that whatever you're trying to find, the angle is always across it, right? So if you're using, for example, F here, you're going to use the angle beta because it's way across it, right? So if you're using F1 here, it depends on where you want to use it. If you're using the F1 from here, so you take the angle alpha here. If you take the F1 here, you take the angle here, right? Same thing as F2 here. If you want to find F2 here, you take the angle across it, theta, right? So that's how you get the sine formula here. F1, this is the angle across it, the angle across it, and the angle across it, right? So from this sine formula here, you can get the magnitude, either F1 or F2, all right? This is the F resultant, the resultant force, okay? So once you resolve it, use the sine formula to find the magnitude of force in the x direction and in the y direction, right? But because this is non-perpendicular, we use F1 and F2, right? Because it exists both in the x and the y direction, right? Because it's non-perpendicular, so there is an x here and there is also a y, okay? So that's it for trying to find the magnitude, which is using the sine formula. Okay, so this is the question, all right? So I think it's easier for me to show you how to resolve the forces than just explaining the theory behind it, all right? So basically, you have to look back at the question here. So a structure consists of member A, B, and AC. So A, B, and AC subjected to a force of 10 kilonewton that makes an angle of 20° against the horizontal line. So figure here. So calculate the forces in member A, B, and AC. So A, B here, and AC here, and determine whether the member is in compression or tension. Okay, so I'm sure you guys still remember your civil engineering materials, right? Compression is when a material is compressed, means the force is pushed inwards, and tension, and it is in tensile. The tensile strength means you are pushing it apart. The forces goes outwards. All right. So it wants to know which one is compressed and which one is in tension. All right. So the first thing that you need to do when you look at this is what? Anyone? You need to always draw the free body diagram, right? Only when drawing the free body diagram, then it starts to make sense to you when you are solving the calculation, right? Because for example, here it's a bit hard when you look at the figure, right? It's a bit hard to solve, but if you do enough practice, then you start to see it clearly. For example, you can make everything into triangles. When you make everything into triangles, it's easier to solve, right? So how many triangles can you make from this figure, right? So this one here, and you can close the loop here, and then you get one triangle. And then if you close the loop here some more, you have two triangles, right? And then if you close the loop here some more, now you have three triangles. You have triangle 1, triangle 2, and triangle 3. Okay, so that's the beauty of drawing the free body diagram. If you draw it really neatly and systematically, then you start to see the whole picture. If you don't, then you will get confused by all these magnitude and angles that I'm putting into question, right? Some angles do not even make sense. I'm just putting it there to make you confused, all right? So you have to draw your own free body diagram so that you can see the overall picture and how you can solve the problem. All right, so once you draw the free body diagram here, you will get something like this. All right, so all the things in red here, the red coded one, are not going to be given in the exam. The red things here is that what you need to put in your free body diagrams and find to solve the problem. All right, so if you look back at the free body diagram on the left here, right? So if you close the loop and make it into triangle, and then make it triangle here, you have 1, 2, 3 triangles, right? But when you look at it, right, what you need to find is this one, right? The force AB and then force AC, because this is the resultant force, right? This is the resultant force, so you need to resolve it. So you resolve it first. So make a parallel box here. So your first force will be here, and then another force will be here. This one is actually this one, right? So you resolve it. This is your resultant force that was given in the question. So you resolve it. So this will be your force AC, and then this will be your force AB, right? So the question wants you to find this two force that has been resolved from this resultant force here. But you cannot solve it because you don't have enough data, right? So if you can see here, the triangle here, right? There's no angle given here at all. There's only given an angle here, which is 20 degree, which is somewhere here, right? So you cannot solve this one. You cannot find the magnitude of AB and AC here because there's no angle given here, right? But you can solve the triangle here and find the angle gamma here, right? So systematically, if you look back at the question, you need to solve the first triangle first. Once you solve the first triangle, you will have enough data to solve the second triangle, right? Once you have enough data in the second triangle, you can now move on to the third triangle and solve it, right? So the data that you have here will enable you to solve this triangle here. And once you solve the triangle here, you have enough data, you have enough angle, then you can use that to solve the triangle here, right? So we go and solve this triangle here first. The magnitude is given for this one, 0.5. It's also given the magnitude 4 here. So it's easy, right? You just have to calculate the hypotenuse here, and then you can also calculate the angle here, which is gamma. All right. So BC, B to C here, this is the hypotenuse. So we just use the Pythagoras theorem, right? 0.5 square plus 4 square. All right, just use basic Pythagoras theorem to find hypotenuse. So 4.03. So your BC here will be 4.03, right? And then you can find gamma as well. So gamma is basically 0.5 divided by 4 using tan, right? Tan is equals to opposite over adjacent, right? So opposite is 0.5, adjacent divided by 4. So 0.4 divided by 4 will have your gamma, which is 7.1 degree. All right. So now the first triangle is solved. We have the magnitude for BC and we have gamma here, the angle between BC and origin here. Okay, so once we have BC here, which is 4.03, right, we can solve the second triangle here, right? Because this is what we found, which is 4.03. This is already given in the question, which is 2. And this is also given in the question, which is 3, right? So we have the magnitudes for AB, AC, and BC. Okay, so once we have the magnitude, we can use the cosine rule, right? You have to remember between using the sine rule and the cosine rule, you have to choose whichever data that you have sufficient enough to use that equation. So at the moment, we have sufficient data to use the cosine rule, right? We have BC, so BC square plus 2, which is this one, plus 3 square minus 2, 2 and 3, and then cos theta, all right? So BC, remember, if you are taking BC here, the angle must be across it. All right. So now we have only one unknown, which is theta here. And now we can calculate that unknown and find the theta for this one, right? Because BC is already known, 4.003, 2 given the question, 3 given the question. Same thing here, 2, 3, and given the question. So only one unknown theta, which we can find, right? So calculate this one, and finally you have theta, which is 105.7 degree. So this one is 105.7 degree, right? Easier to calculate because now we have all three magnitudes, right? So now, after we have calculated theta here, we can calculate this angle here, which is eta. So this one is called eta, and we can calculate it. How? By using the sine rule, right? We have sufficient data to use the sine rule here, right? For example, 2 divided by sine eta equals to BC here divided by sine theta here. So we have this data, we have BC, we have AB, but we don't have eta. So there's just only one unknown. We can directly solve it, right? So eta here will be 28.5 degree. So here it will be 28.5 degree, right? So now we have solved the second triangle. Now the data that we have from the second triangle, we can incorporate it into this part here, the triangle that we want to solve at the first place, but we cannot because we don't have enough data, right? So as you can see here, if you try to remember your trigonometry, right? Alpha here is the same as alpha here, right? Because this one is z, right? So alpha here is the same as alpha here, right? So you can straight away put alpha here, alpha here, right? So alpha is basically gamma plus eta, right? We have the value for gamma and we have the value for eta that we have just calculated, right? So this one is equivalent to this one, okay? So what else can we incorporate data from the second triangle to the third triangle, right? So at this point, you have to really brush up on your trigonometry. All right. This one here, theta here, is also equivalent to here, right? Because of the trigonometric principle. So the one that we have just calculated here will be equals to here. The angle is the same, right? So just moving the angles around because of the trigonometric principles, right? So this is alpha that I've just told you. Alpha here is equals to eta plus gamma. So 28.5 plus 7.1 degree, you will have your alpha, which is 35.6 degree. After you have this one, 35.6 degree, you can straight away put it here in the first triangle, in the third triangle that we want to calculate, right? So alpha will be here. Okay. So now we can solve the angles for the third triangle because we have enough data to solve it now, right? So alpha here is equals to, so beta here is equals to alpha minus 20 degree, because as you can see here, the alpha also includes the 20 degree here. It includes the 20 degree there, right? So you need to calculate that angle where it does not require the 20 degree, because you just want to find the angle here, right? So this one, we need to subtract this one from the alpha to get the beta, right? So beta is equals to alpha minus 20 degree. Once you get that, you have beta here. And then theta here, if we've already calculated that, we're just transferring this one to this one, right? So we now have the angle for beta, we have the angle for theta. We can now calculate lambda here. How we can calculate the lambda? This is triangle, right? This is triangle, so a triangle is 180 degree, right? So 180 degree minus the beta here minus the angle theta here, you will get your lambda, which is 58.7 degree, right? Now we have the angles for this one, and for this one. We can now use the sine rule to find FAC and FAB, because we have sufficient data. We have all the angles now at different sides, so we can use the sine rule, right? So you're just substituting all the angle into the sine rule here. So if you want to find FAB, so FAB So FAB is this one, right? FAB. So opposite of it is beta. So divide by sine beta equals to FAC sine lambda. So this one equals to the resultant force here, and then the opposite of it, sine theta. So this one equals to this one equals to this one. You can straight away solve it and find your magnitude, FAB and FAC, right? So this one, this is basic math. You can resolve it. And finally, you have your FAB 2.79 kilonewton and FAC 8.88 kilonewton, right? Finally, now you have finally successfully resolved your forces, and you know the magnitude for those two forces that you have resolved, all right? So now it wants to ask, it asks you how to determine which member is in tension, is which member is in compression, right? So AB is force AB here, it's 2.79 kilonewton. So this one is in tension, right? Because it's being pulled apart, right? Whereas for FAC here, the force is this one, so it's being compressed. The forces is pushed inwards, so this one is in compression, right? So AB is in tension, AC is in compression because it's being compressed. The forces is pushed inwards, whereas for this one, the forces are pulled apart from each other, all right? So I think that's it for question 6. So anyone has any questions for this question? Everyone okay with it? Okay, everyone good? Anyone needs to ask any questions?
Sorry, doctor.
Okay. All right. Okay.
Hello?
A question isn't.
Hello?
Hello?
Hello? Can you hear me,
Hello?
doctor?
Yeah, Hussam. Yeah, okay, yeah.
Are these related to the last week lecture?
Yes.
Because I haven't attended last week lecture because I wasn't registered for this course.
You didn't you were not present last week?
Yeah, I did visit last week.
You did? Did you
No, I
attend my
didn't.
class? Oh, you
No,
didn't.
no.
Okay. So you need to go back and study up for last week's chapter, which is the resultant of forces, right? It's actually you need to first know how to find the resultant force first. Then only you can resolve the forces, right? So after this, I want you to go through back to the lecture notes to the first half of this chapter 2, which is the calculation of resultant force. Resultant force is basically you have a lot of forces, but you want to merge it into one singular force, which is the resultant, right? There's a method on how to do it, but you have to learn it first. Okay. So after this, go back and learn the earlier chapters first. And now for this chapter that I'm teaching is we have one resultant force. We are trying to break it apart into two forces, right? So
Okay,
each
doctor.
has their own method. So what I'm teaching now is the method of resolving the forces. Last week, there's another method to calculate the resultant of forces. Okay, so you need to know how to calculate the resultant, and then now resolving, and after this, we're going to combine the two and calculate the resultant and the resolving of forces. Okay.
Okay, doctor. But did you record the lecture for last week? Or how?
No, I did not record it, but maybe you can ask your friends how to calculate the methods and so on. All right, or maybe you can just try to do it, and if you have any questions, you can just WhatsApp me or something like that.
Okay, doctor. Thank you.
All right. Okay, so that's it for solution 6, right? So right now, what we are doing is just calculating the resolving. We're just trying to break apart the resultant forces. All right. So for question 7, when force P is resolved into components in the x and y direction, the component P in the x direction is 500 Newton. When force P is resolved, so the key word here is resolve, right? Whenever you see or hear the words resolve, means a resultant force is currently broken apart into two. All right. Components P in the x direction is 800 Newton. Determine magnitude P components P in the y and y prime direction, right? So we have an xy direction here, and the angle is 20 degree. And then it's going to move upwards into the y prime and x prime direction, and it wants you to figure out the magnitude of P and P when it is moved in the y prime direction and the original y axis here, right? So the first thing that you need to do is draw the free body diagram so that it's easier for you to analyze the whole system, right? So this is the original axis. So x and y, original axis. So it's px is already given. Py is the one that we need to find, right? So the angle here is beta plus 20 degree. And this is y prime and x prime, right? When we move it, we try to move it upwards a little so the axis changes, right? So when the axis changes, this is the x prime and this is the y prime, right? So the px prime is already given, which is 800 Newton. And then the angle here is beta, and py prime here is what we need to find. We need to find the p at the original y-axis, and you need to find p at y prime axis when it is moved up a little bit, right? So the second thing that you need to do is you need to list the equation here, right? So Px is equals to P cos beta plus 20 degree is equals to 500 Newton, right? Because those are the only data that we have. We do not have any Y data for both of this, but we have data in the X direction, right? So we list it out. So P cos beta plus 20 degree. Okay, so this is this one. We use cos because adjacent over hypotenuse, right? Adjacent here. So 500 Newton. Next one is this one. So P x prime is equals to P cos beta, right? So it's equals to 500 Newton here, equals to 800 Newton here, right? Now you have to be creative when you are at this stage, right? So how do we solve when we have two unknowns? It's basically unsolvable, right? It's hard to solve when you have two unknowns. You have to make it into one unknown, then it's easier for us to solve it. So what we can do here from equation 1 and equation 2, we can try to divide equation 1 and equation 2 by itself. When we divide these two, we will remove P here, right? So we divide equation 1 and equation 2. So once we divide it, we remove the second unknown, which is P, right? So now we only have one unknown, which is beta, which is now something that we can solve, all right? So divide P cos beta and everything, and finally we will have this one, okay? Cos beta plus 20 degree equals to 0.25 cos beta. So now how can we solve this one? Okay, it is solvable if you remember back to your trigonometry, right? Remember your trigonometric identities. So I've put in a table here for you to recap, all right? So cos beta plus 20 degree here is actually this one here. So it's the same thing, right? It's trigonometric identities. So now you can change this one into this format here because of the trigonometric identity. See, cos alpha plus beta is the same thing, right? So you can change it into something like this so that it's easier for us to solve it, right? So change it and finally you will have something like this. Cos beta cos 20 degree minus sine beta sine 20 degree minus 0.25 cos beta, right? Now, if you take this one and move it to the left side, right? So cos beta cos 20 degree divided by cos beta. So this one cancels each other out, right? So now you have cos 20 degree. Okay, same thing like this one. If you divide it with cos beta here, sine divided by cos, you will have tan, right? Sine divided by cos is tan. So tan beta sine 20 degree, right? Now for this one, we can definitely solve it because there's only one unknown. So solve this one, it's just basic maths, and finally you will have your beta, which is 42.6 degree. Okay, so now once we have our beta, it's easy. Just take this one and put it back into the original equation here, right? So once you put your beta here, you will get our P, right? And then if you put your beta here also, we can get our P in the Y prime direction, right? Just put it back, the beta, into equation 1 and equation 2, right? So once you put it back into equation 1, equation 2, you will have your Py in the original y-axis, 964.9 Newton, and Py prime, which is 735.6 Newton, right? So now you have answered the question. We have already found the magnitude of P in the y direction and magnitude of P in the y direction. All right. So everyone okay? Basically, it's just trigonometry and trigonometric identities, right? You just have to be aware of the problem and try to draw the free body diagram as you see fit, and then just removing one unknowns at a time until you can actually solve it, right? So you can see here, first you have two unknowns, you cannot solve it. So you have to be creative about it, right? So you divide equation 1 and equation 2, but you cannot just remove the unknowns as you like. It has to follow the laws of mathematics and the laws of trigonometry, right? So you have to follow the laws and the rules and try to remove one unknown at a time, right? So we have two unknowns here. So you have to be creative about it. Sometimes you divide it, sometimes you multiply it with something, right? As long as you can remove the one unknown, so it's solvable, right? If it's just one unknown, it is solvable. But remember, you have to follow the rules and laws of mathematics and trigonometry. You cannot just remove one unknown just because you like it, right? So this one, we can divide it, and then we remove p, and we have one unknown. And once we have one unknown, it's practically solvable, right? We'll get this one and use trigonometric identities, change it to this part here, rearrange it, and finally you have your beta, which is 42.6 degrees. Okay, so I think that's it for the resolving of forces. So I'm sure it's not that hard, right? Resolving is just the first part, you have your resultant force. The first part is just for you to resolve it into x and y component, fx and fy. Then from there, you just use trigonometry, using angles and so on to find the magnitude or to find the angle. All right. So everyone okay? Everyone okay with resolution of forces? The breaking apart of the resultant forces? Okay, good, good, good. Thumbs up. All right, okay. Yep, some?
Are the equations that was given in the last example, are they given
Which equation?
or we need to find it out? The equations, the last
You
example.
mean this one?
No, the last bit. The
The
one before.
last bit, which is
Yeah, this
this one?
No, go to after it.
After it.
2 pages after it. Yeah.
This one?
No, the one after it. Yes, this one. This
This one?
equation.
Which
Yeah.
equation?
The one in the bottom. Yeah.
This one?
Are they? Yeah. Are they given or that we need to find it out?
No, it's not. This is not an equation to solve something. This is just basically this one. You are rearranging it, right? P cos beta plus 20 degree, right? This is a triangle, right? So cos is adjacent over adjacent over hypotenuse, right? So it's P cos beta and 500. This is not an equation like the cosine rule or the sine rule. This is just the equation for these two here, and it will change depending on the figure.
Oh, okay. I see. Okay,
Yeah, because you it's just rearranging it, right? Px is already given, which is 500 Newton. So how do we find the 500 Newton? It's just breaking apart. It's just P cos beta plus this is how you get 500 Newton, right? Because we want to extract the unknown here, which is beta. Right?
Oh, okay. Yes, I get it.
Yeah.
Yes.
Yeah. So it's just the same thing. We are using cos here because it's adjacent over hypotenuse, right? So Hussam, I recommend for you to go back to your resultant and forces and try to understand that one first before you move on to the resolving forces, all right?
Yeah, okay, Doc.
Okay, don't worry, it's not that hard. This is still the first chapter, so it's not that hard to grasp, right?
Yeah, sure.
Okay, so now after we have learned about the resultant and the resolution of forces, now is the resultant of coplanar force system. Now we need to combine the two, all right? Why do we need to combine the resultant and resolving of forces? It's because we want to solve the coplanar force system. We want to find the resultant of a coplanar force system. So previously, what we are solving is just one force, right? It's just one force. So it's easier, right? We can resolve it easier. We can find the resultant easy. But what happens when you have a lot of forces like this one? You have 1, 2, 3, 4 forces here, right? So it's difficult. It's difficult to do it. If it's difficult, it looks difficult, but actually it's not that difficult. What you have to do is you just have to follow the system that I've just told you, which is resolve it first and find the resultant force later. All right. So do it one by one so you don't get confused. For example, you have force 1 here, you have force 2 here, you have force 3 here, and then you have force 4 here, right? So resolve it one by one, right? So this is the first force that has been resolved. This is the second force that has been resolved, third force that has been resolved, and fourth force that has been resolved. Meant this is the resultant force, right? So this part, it has resolved it into the y and x direction. Same thing here, you have one force, you resolve it, and you have this one, y and x. Y, x and y, x and y. All right? Basically just taking resultant force and breaking it apart into the x and y direction. Okay, so once you have broke it apart into the x and y direction, you just add everything that is in the same plane. Okay, so for example, in the x direction, you take everything that is in the x direction and you add it together to find the resultant force in the x direction. Okay, the same thing like y, you take everything in the y direction because they are on the same plane, in the y plane, right? And you add them together to find the resultant force in the y direction. Okay, so you get something like this. Sum of forces in the x direction, F1x plus F2 minus F3 minus F4x, right? It's minus because they are going to the left, right? You have to remember your coordinate system. This one is positive, right? This one is negative. Whatever is going up and to the right is positive. Whatever is going to the left and going down is negative, right? So be careful about the signage here, right? So everything that is in the x direction, you add them all up, right? But don't forget about the signage. The same thing about the y direction, you add them all up, right? So this is just cos and sine. This one depends on the angle, right? Sometimes for the x direction, you use sine, sometimes you use cos. It depends where your angle is, okay? After you found the resultant force in the x direction and the resultant force in the y direction, which is this one, right? You can use Pythagoras theorem to find your resultant force, right? And once you found the resultant force, it's easy for you to calculate the direction, which is theta here is tan equals to Fy divided by x, right? But depending on the question, if it wants horizontal, then you take the angle here. But if it wants the vertical, then you take the angle this one, right? Depends on the question. This is the horizontal angle. This is the vertical angle. Okay. So I think it's easier for me to show you how to calculate it using an exercise, right? So this is question 8. So a force system of 60 Newton, 80 Newton, and so on on the same plane, which is plane XY. Find the resultant force and angle, which is you need to find the magnitude and you need to find the direction, right? Made by the resultant force against the horizontal force. So horizontal force is the angle that is on the X plane, right? If it's vertical, then it's the angle on the vertical plane. But this is horizontal, so it's the on the horizontal on the X plane. All right. So the first thing that you can do is you need to draw your free body diagram first. After you have drawn your free body diagram, you have to solve this systematically. All right. So there's how much? There's 3 forces here. There's the first force here, the second force here, and then you have your third force here. Right. So we need to solve it one by one, right? It looks complicated, but once you solve it one by one, it gets easier, all right? So you need to resolve it first. For this one, can you resolve it? No, you can't resolve it because it's already on the y plane. There's no x plane for this force. It exists only on the y plane only. So x is 0, and then your y is equals to the magnitude times 100 Newton. All right. So no. The x is equals to 0. The y is 100 Newton. Right? There's no need to find anything because it's already given. It exists on that plane. Y is all automatically 100 Newton. You don't need to calculate it anymore. Right? Now we go to the second forces, which is this one. Right? So if we make a triangle out of it, this is a triangle, right? So the x plane here is 60 cos 40 degree, right? And it's positive because it's going in the positive direction, right? Same thing, if you make a triangle here, the y part here is 60 sine 40 degree, and it's minus because it's going down into the negative direction. Okay, and then if you go to the third forces here and you make a triangle, no, that's hard. You make a triangle here, right? You make a triangle here, and then if you want to calculate the horizontal part, which is this one, so it's 80 cos 30 degree. All right, and it's in going to the left, so it's negative 80 cos 30 degree. And if you want to calculate the vertical part, which is this one, so it's 80 sine 30 degree, right? And it's also negative because it's going downwards in the negative direction, right? So I recommend for you guys to draw a table, right? Once you draw a table, it's actually very easy to calculate. You draw a table and make one row for force 1, force 2, and force 3. And then whatever that you have calculated in the x direction, put it into one column, and whatever you calculate in the y direction, you put it into another column, right? So as you can see, this is force 1, right? It exists on the y plane, so x is automatically 0, y is definitely 100 Newton, right? Just put it into the box here. Same thing, force number 2 here, all right? So if you want to find this part here, it's 60 cos 40 degree. And if you want to find the vertical part here, it's 60 sine 40, but negative because it's going down. Okay, same thing like this one. If you make a triangle here, to find this part is 80 cos 30 degree. Sorry, 80 sine 60 degree, right? Because sine is opposite over hypotenuse. So 80 sine 30 degree. And to find this one here is 80 cos 30 degree because adjacent over hypotenuse, right? And then the angle is both negative because in the x direction it's going to the left, it's negative, and in the y direction it's going down, also negative, right? So after you have organized them into this table here, just add them up. So fx, the sum of fx, add this one up, it's 5.96 Newton. All right. And in the y direction, add them all up, you will have minus 7.85 Newton, right? So now you have resultant force, you have your force, sum of force in x direction and sum of force in the y direction. Now you can calculate the resultant force for this one, right? Sum of fx, you know it's 5.96 in the positive direction. So it's probably going here, 5.96. And then for y direction, it's negative 7.85. So it's going down, 7.85, right? So your resultant force will be here. This will be your resultant force. Okay? So draw the free body diagram. You have your sum of forces in the x direction and sum of forces in the y direction. So your resultant force is this one. Okay. Once you have your resultant force, you look back at the question. It wants the angle to the horizontal line. So the x direction is the horizontal line. So the angle that you need to find is this one, right? So it's just basically tan theta, tan adjacent of a hypotenuse. So 7.85 divided by 5.996. Okay. So get this one, 52.8. And then to calculate the resultant force, it's just basically using Pythagoras theorem, right? It's this one plus this one, square root it, you get 9.86. Okay, this part is the easiest part. Once you have calculated the resultant, once you found the sum of forces in the x and y direction, then it's just a matter of drawing the resultant force, calculating it using Pythagoras theorem, and then finding the direction, the angle, which is using tan theta or cos or sine, depending on where the angle is and what the question wants. If the question wants horizontal component, you use the angle here. If it wants the vertical components, use the angle here, or you just use sine, theta, and so on to find the magnitude here. So, okay. So that's for question 8. So now we go to the last question. It's the same thing. Figure noun shows a truss consisting of steel members connected by a gusset plate and so on. So first determine the resultant force for all 4 forces. So all these forces, to question 1, only one resultant forces that represent all these forces. All right, so that it's easier for us to analyze the system if it's just one forces. Okay, and then determine the angle made by the resultant force against the positive x-axis. All right, so the angle must be somewhere here, positive x-axis going to the right. Okay, so draw your free body diagram and make a table. Right, once you make it into a table, it becomes easier. So we have 4 forces, list down all the 4 forces, and then calculate the force in the x direction, and calculate the force in the y direction for each and every one here. All right, so it's not that hard. Just make a triangle out of every forces here. Right, make a triangle here, and then make another triangle here. This one also make a triangle here. This one no need to make a triangle because x is 0, y is 40 kilonewton automatically, right? Because it's not slanted, it's perpendicular, right? So you just need to calculate the cos and sines for these 3 here. Okay, so put everything into the box here. Don't make mistakes on the signage. All right, if it's going up in the y direction, it's positive. Going down, it's negative. For the x direction, if it's going to the left, it's negative. It's going to the right, it's positive, right? So just put everything. Once you make it into triangles, you calculate it. So just put everything into the box here. Once you have put everything into the box, you can calculate the sum of the force in the x direction and the sum of the forces in the y direction, right? So sum everything up here, you'll get 34.90 kilonewton. All right. Same thing here, you get 41.80 kilonewton here, right? Once you have the force, the sum of the forces in the x and y direction, we can now draw our resultant force. So sum of force in the x direction is 34.90 kilonewton. So it's positive, so it's going to the right. And then in the y direction is 41.80 kilonewton positive, so it's going upwards, right? So your resultant force will be here. Okay, once we draw where the resultant force is, we can straight away calculate the magnitude of the resultant force. The magnitude is just Pythagoras theorem, right? Sum of fx in the y direction, sum of fy in the right direction, you get your magnitude, which is 54.5. Right? Then you need to find the angle. It wants to find the angle against the positive x-axis. So if we draw back, it will be here, the positive x-axis. So it's just using basic trigonometry. So tan inverse 48.1 kilonewton divided by 34.9 kilonewton, you will get your angle, which is 50.1 degree. All right. So it's not that hard. Eventually, what we have learned last week and today all combine to solve problems like this, where you have a lot of forces, right? So you combine it into one resultant forces, okay? But in order to do that, you have to resolve each and one of these forces here first. Then once you have resolved it, you can straight away calculate one big resultant forces from that resolution of forces. All right. So don't worry, even if you have, for example, 10 forces here, right? It's just if you know the method well, then it's easy for you to do it, right? No matter how many forces there are, right? Just do it one by one. Make a table here and just list the forces one by one. And then start to calculate your forces in the x direction and start to calculate it in the y direction, right? It's easy to resolve it. Make it into triangles, everything. Make it into triangles so that you can get the cos and sines out of it, right? In the x and y direction. And then just add them all up. And once you add them all up, it's easy for you to calculate the resultant force, because resultant force is just Pythagoras theorem, and the angle is just basically using tan divided by the magnitude of that particular direction. Okay, so I think that's it for today. Anyone has any questions regarding this? Well, question 9, question 8, everyone okay? Okay, thumbs up if you're okay. Okay, good. All right, so I think this is actually not that hard. This chapter is not that hard. 2D, 3D, and so on is not that hard, but it is a bit confusing, right? So the only way to tackle problems like this is if you do a lot of exercise. You need to do a lot of exercise, right? Because it's just finding angles, finding magnitude, and so on. It's just very easy. And then there's just two formula for this chapter: cosine rule and sine rule. Just that two, right? The formula is just two: cosine rule and sine rule. And use either one depending on the data that you have. If you have sufficient data to use sine rule, use sine rule. If you have sufficient data for cosine, use cosine rule. Only two formula. The rest is all your basic maths, your trigonometry, trigonometric identities, how you look at the angles, depending on the trigonometry law and so on, right? So please do an example, because next week we are going to learn the same thing, resolving and resolution of forces, but this time in 3 dimension, right? So 3 dimension, now we are resolving it into the z, x, and y direction, right? So you need to brush up your resolving and resolution of forces in 2D, so that next week when you go to 3D, you will not get confused, right? So these are the tutorial questions. So please try to do it. It's not that hard. For example, like this one, right? You have 3 forces. Just make a table and resolve the forces one by one, each one, right? Same thing here. It looks complicated because you have not drawn the free body diagram. Once you have drawn the free body diagram, it will not be that intimidating, right? So please try to do the tutorials. I think there are already students assigned to these questions. So from now on, starting from this week, we will have tutorials, right? But the tutorials will not be live like this one, okay? As we have discussed, I think some of you were not present last week. So during this online session until Raya, right, we will have a recorded video tutorial session, right? So how this work is that you need to assign your name in the tutorial list. Once you do that, you have to, once your time arrives, right, to do that tutorial, you have to do tutorial, you have to record yourself, doing the tutorials and explaining solution, and then you need to upload your video. All right, so you need to upload your video 1 day before the tutorial session, which is Thursday. So we have our tutorial on Thursday, so everyone that is assigned to that question needs to submit their video tutorial by Wednesday before 5 o'clock. All right. So if you have already put your name for that question, you need to submit your video tutorial by Wednesday before 5 p.m. so that I can check. And then on Thursday, I will upload the video on ITEL along with the attendance sheet, the OBE attendance, and then you can do your own studying at your own time, right? So you can start to do the tutorials, and if you got stuck, then you can look at the video solution that have been prepared by your classmates, right? So to those who are preparing the video, right, make sure that your answer is correct, right? So I've already put the answers here. If you got the answers correct, then you are correct, right? If you don't, then you have to redo it until you get the correct answers, or you can approach me and I will check your solution, and then we have to, and then you can solve it by yourself later, all right? But make sure to upload the correct solution in your video, all right? So make sure you try to do it first, get the correct answers. After you get the correct answers, then you do your video, right? When you do your video, it's up to you. You can solve it while explaining, like, okay, this is y x plus c and then 2a plus b. You can do it like that, or you can have the solution ready and just explaining to them, okay, this one is 2a plus b, this is what I meant by this one. But it has to be clear, all right? It has to be clear so that the rest of your classmates can understand. And if any one of you gets stuck, they can just look at the video and learn from that tutorial session. Okay, so remember, submit to those students who have assigned themselves this week's tutorial. You have to submit by Wednesday before 5 p.m. Okay, and remember, every Thursday I will post the OBE attendance, right? So there's no more reason for you to not sign the attendance, saying that you forgot to sign the attendance. So on every Thursday I will post the attendance, and I will close the link at 5 p.m. right? So you have to sign your OBE attendance anywhere as long as it's before 5 p.m. Okay, everyone clear? Okay, good. Everyone clear? Okay, good. So I think that's it for today. Let me get the attendance. Please don't forget to sign your attendance, all right? So this is the attendance. All right, so I'll see you guys next week on Monday, right? And don't forget to sign your attendance on Thursday, which I will post on ITEL, along with the video solutions. Okay, so that's it for today. I'll see you guys next week. Bye. Okay,
Thank
all
you,
right.
Doctor.
Thank you,
Okay,
Doctor.
Doctor.
All right, bye. See you next week.
Thank you, Doctor.
Okay, bye.